Okay, so this problem 560, subarray sum equals k. Medium problem. Given an array of integers nums and an integer k, return the total number of subarrays whose sum equals to k. Subarray is a contiguous non-empty sequence of elements within an array. Here you got 1, 1, 1, k equals 2, output 2 because you got 1, 1 here and a 1, 1 here. Then we got 1, 2, 3, k equals 3, so you got 1, 2, which is 3, and then 3, which is 3, so you got 2. Okay. And then let's do another example. So nums, let's say you got k equals 3. So you got 1, 9, 14 minus 7, and so on. So let's say 1 and 9, that's 10. That's obviously not 3. 9 and 14 is 23. 1, 9 and 14. So basically we need the sum of the entire subarray entire array that we're looking at for a given index, but we also need the sum of the subarrays up to the given index. So let's say this is the given index. We don't want just the sum of 1, 9, 14, but we want the sum of 9 and 14 also. And if we go to the minus 7 here, we don't want just this sum, but we want this sum and this one. So it would help a lot if we had like a prefix sum that we're keeping track of. So this would be 1, 10, 24, and then 17. So, okay, so this makes things easier. So now we got the 10, but we also know, so the 9 and a 10, we check both of those. None of them are equal to 3. Then we got 24, and then we could do 24 minus the 1, which is 23, which is this subarray. And then 24 minus the 10, which is the 14, which is this subarray here. Then 17 is this entire subarray. The sum of this subarray is the 17 minus the 1. Then the subarray of this is just the 17 minus the 10. Yeah, so then let's say we got another one here, minus 15. So we're at 2. So we look at this entire subarray. Then we look at this one. The sum of this is the 2 minus the 1. So 1. This subarray is 2 minus the 10. So basically to get the sum of a given subarray, we could look at the prefix at a given, at the element we're looking at, but also subtracted by the prefix that already existed. So that's something to keep in mind to check if subarray equals k. Look at look at prefix at sum at I minus prefix at j. So j would be like here, for example. Yeah. So then when we get, let's say, 13, so this would be 11. 13, and then 13 minus 3 is 10, and we have the 10 here. So that means this subarray must be 3, which is 7 minus 8 plus 11. Yeah, so it is indeed 3. So we have res equals 0. Increment res when prefix minus. So what you could do is we could have like a dictionary. So then when prefix minus k is in dict. So as an example, 13 minus 3 equals 10, which exists in dictionary. So the dictionary the keys would be each of these prefixes. So what would a value be? So something that comes to mind is, let's say you have 5 here, 18, then minus 8, a 10. So you have a 10 and a 10 here. So we know, so let's say we got like dictionary here. So 1, 1, because the 10, that's the first time it's occurred. 24, first time it's occurred. 17, first time. 1, 1, and then this would be 2 because this is the second time you have a 10. So then let's say you hit it 13 again. So let's say you got 4, so 14, minus 1, so 13. So here you got 13 minus a 3, which is a 10, and that existed twice. So that means you have two subarrays. You got this one here, which is 3, and then this whole thing has to have some 3. So then you're not just incrementing res by 1 when prefix minus k is in dictionary, you're incrementing res by dict of prefix minus k when prefix minus k is in dictionary, because you want res to be incremented by 2 because the 13 you have the 10 occurring twice. So we got these two conditions. Another thing we need to keep track of is let's say you just have the number 3. Let's say you have a prefix of just 3. So let's say you got minus 10 here. So you got 3. So in this case, prefix is prefix sum is 3 and then k is 3, so 0. But 0 doesn't already exist in this dictionary. So, but we still want to increment it by 1. So what we could do is just have 0 as 1 initially. So then now, so you increment this by 1 because 3 minus 3, which is 0, is in the dictionary. So it looks like we should be all the conditions we would need. So we could just iterate through the nums list for I in range length of nums res dict equals 0 and empty dictionary. Oh, not empty dictionary, 0 of 1. Then so increment res by, okay, so check if prefix minus k in dict. If it is, then dict of prefix minus k. And then see here. Yeah, so that's basically this part. And then we also need to add the elements to the dictionary. So here when we get the 1, so we check if 1 minus 3, which is minus 2, is in there. Minus 2 is not in the dictionary, so then we don't increment res, and then now we input 1 into the dictionary. So if prefix not in dict, then dict of prefix equals 1, else dict of prefix plus equals to 1, and that's this case here, 10 and then the 10. And then just return res. And that should do it. Let's just run through this example. 1, 1, 1, k equals 2. So first, let's see. So 1, 1, 1, the prefix would be 1, 2, and 3. Okay, so prefix is 1 minus 1, which is 0. Oh, no, 1 minus 2, which is minus 1. That's not in the dictionary. So now we have 0, 1, and then 1, 1. So now you go here. 2 minus k, which is 2, which is 0. 0 is in the dictionary, so now res is 1. And now the prefix is 2. And now you go to the 3. 3 minus k, which is 2, is 1. So the result of that is 1. And 1 is in the dictionary. So now you increase it by 1, so now you get 2. So that's matches this output. And then the same thing would probably apply for here. So let's just run this code. Oh, prefix. Oh, I didn't even. And it passes. So yeah, that's it for this problem. Thanks so much for watching.